In 1977, humanity sent two machines toward the outer planets. They were built using technology less powerful than a modern smartphone. Inside a NASA clean room, engineers in white lab coats and hairnets meticulously inspect the twin Voyager probes under bright, sterile fluorescent lights. No one imagined that almost 50 years later, they would still be speaking to Earth from beyond the Sun's protective frontier. Their mission was born from a rare celestial event, a grand tour made possible by a planetary alignment occurring only once every 176 years. Voyager 1 and 2 set out on diverging paths, using the gravity of these giants to slingshot themselves deeper into the dark unknown. Attached to each craft is a golden record, a time capsule carrying the sounds and images of Earth to any intelligence that might find it. The probes relied on the high-gain dish antenna, their only voice across billions of miles, and long booms carrying sensitive scientific instruments. But in the freezing darkness far from the sun, solar panels were useless. The machines needed a different kind of heart. They were powered by radioisotope thermoelectric generators, converting the heat from decaying plutonium into steady, silent electricity. This nuclear battery has allowed them to survive the most hostile environment known to man for nearly half a century. In August 1977, Voyager 2 launched atop a Titan IIIe rocket, followed weeks later by the faster Voyager 1, beginning their eternal journey. As the years passed, Earth faded into a tiny speck. Voyager 1 surged ahead, eventually reaching the swirling, violent clouds of Jupiter. They began as planetary explorers, but their final destination would be somewhere no human-made object had ever traveled: interstellar space. Even now, the probes continue to pulse. A weak signal, traveling at the speed of light, carries data from the edge of the galaxy. They are our silent ambassadors drifting forever into the infinite archive of the stars.
In the silent halls of a cosmic library, the history of our exploration is etched in light. A journey that redefined our place in the stars. Two machines, Voyager 1 and 2, left Earth in 1977, embarking on a grand tour of the outer solar system that no one had ever attempted. The first giant to greet them was Jupiter, a world so massive it commands its own mini-solar system of moons and swirling radiation belts. Its great red spot, a storm 3 times the size of Earth, raged below. A violent, beautiful reminder of the raw power within gas giants. Nearby, the moon Io revealed a hellish landscape. Voyager witnessed active volcanoes for the first time outside of Earth, spewing sulfur into the vacuum. Then came Saturn, the jewel of the solar system. The spacecraft captured the breathtaking complexity of its rings made of billions of icy particles. Voyager 1 and 2 moved in tandem, dancing through the ring planes to reveal the secrets of these massive celestial structures and their shepherd moons. At Titan, Saturn's largest moon, Voyager 1 faced a choice. It dove close to investigate the hazy atmosphere, a decision that changed its path forever. Titan's gravity slung Voyager 1 out of the ecliptic plane. It began a lonely ascent, leaving the planets behind to head into the interstellar dark. But Voyager 2 stayed the course. It traveled further still, reaching Uranus in 1986, a pale, featureless cyan world tilted strangely on its side. Uranus was a mystery of magnetism and ice. Its tilted axis meant its magnetic field corkscrewed through space, unlike anything scientists had ever seen before. By 1989, Voyager 2 reached Neptune, the final giant, a deep azure world of howling winds and the mysterious Great Dark Spot. Neptune's moon. Triton provided the final surprise. Nitrogen geysers erupting from a frozen surface that looked like the skin of a cantaloupe. The grand tour was complete. Neptune faded into a tiny blue speck as Voyager 2 joined its twin in the silent expanse beyond our sun. They carry our music, our voices, and our curiosity. Even when their batteries fail, these messengers will continue their journey across the galaxy. Voyager is more than a mission. it is humanity's reach for the infinite. Our small footprints in the vast, eternal archive of the cosmos.
In the winter of 1990, the Voyager 1 spacecraft reached a lonely frontier. It had soared past the orbit of Neptune, leaving our sun behind. 6 billion kilometers from its birthplace, the craft was a silent pioneer in the dark abyss, heading toward the infinite interstellar void. But before its mission ended, Carl Sagan proposed one final experiment. He wanted Voyager to turn its camera back home for a family portrait. Some at NASA worried the sun's brightness might blind the sensors, but the vision of seeing our world from the edge was worth the risk. On Valentine's Day 1990, the command was sent across the vast emptiness, a signal traveling at the speed of light to the distant craft. Voyager complied. The shutter clicked, capturing 60 frames of the planets, including a small, grainy image that would change our perspective forever. There, caught in a beam of scattered sunlight, was a tiny single pixel of light, a pale blue dot suspended in a sunbeam. Look again at that dot. That's here. That's home. That's us. Every human being you've ever heard of lived out their lives there. The aggregate of our joy and suffering, thousands of confident religions and ideologies, all existing on this mote of dust in the dark. Every king and peasant, every couple in love, every creator and destroyer of civilization lived on that tiny speck of light. Our posturing and imagined self-importance are challenged by this point of pale light. The Earth is a very small stage in a vast arena. It underscores our responsibility to deal more kindly with one another and to preserve and cherish the only home we've ever known. With the final photograph taken, the mission was done. To conserve power, the cameras were commanded to switch off, never to see again. Voyager 1 continued its journey, now a silent sentinel drifting toward the stars, carrying the memories of a tiny world it left behind. Fixed to its side, the golden record remains, a message of music and voices, a legacy for whoever might find us in the eons to come. It showed us ourselves, not as nations or individuals, but as a tiny world surrounded by darkness, a reminder of our shared destiny.
Each spacecraft carries a 30-centimeter gold-plated copper record created as a message from Earth. The record's cover contains symbols that describe how to play it and show Earth's location relative to It contains greetings in 55 languages, natural sounds from Earth, music from different cultures, and 115 images representing human life, science, and our planet. Carl Sagan led the committee that selected its contents, alongside collaborators including Frank Drake and Andrew Yang. The record was not sent toward a known alien civilization. It is a symbolic time capsule that could survive long after human civilization changes or disappears. Voyager carries no weapon and claims no territory. It carries a simple announcement into the darkness: humanity was here.
Deep within the halls of human history, we find the records of our most ambitious journey, a leap into the great unknown that lies beyond our sun. As we pull away from our home, the familiar blue marble of Earth begins to shrink, becoming a lonely speck against the backdrop of an infinite velvet darkness. This is the story of two mechanical pioneers, drifting where no one has gone before. This is Alone in Interstellar Space. Voyager 1, a tireless traveler, moves through a strange blue-tinted haze, the boundary where the sun's influence finally begins to wane. In 2012, it became the first human-made object to cross the heliopause, breaking free from the solar wind and entering the mystery of interstellar space. 6 years later, its twin, Voyager 2, followed suit, plunging into the dark blue void, carrying the same golden message to whatever might be listening. To understand their journey, we must understand the scale. The sun creates a protective bubble called the heliosphere, shielding us from the harsh galactic environment. But the true edge of our solar system is much further. Beyond the planets lies the Oort cloud, a massive shell of icy objects. Even at their incredible speeds, it will take the Voyagers thousands of years to pass through this frozen graveyard and truly leave our home system behind. Today, Voyager 1 is over 25 billion kilometers away. At that distance, the void is absolute, and the silence is deafening. Voyager 2 trails behind at 21 billion kilometers, navigating the deep darkness, a lone sentinel in the outer reaches of our neighborhood. Communication across these distances is a feat of modern physics. When we send a command, it travels at the speed of light. Yet it takes 23 hours for that signal to reach Voyager 1. A message sent today will not be heard until tomorrow. NASA's Deep Space Network, a collection of massive radio antennas across the globe, listens intently for the faintest response. The signal Voyager sends back is a mere 12 watts, equivalent to the power of a refrigerator light bulb, traveling across billions of miles. In the control room, the atmosphere is heavy with anticipation. Engineers wait 2 full days to know if their commands were successful. It is a testament to the longevity of the technology built in the 1970s. These machines were designed to last, and they have far exceeded our expectations. By November 2026, Voyager 1 will reach a historic light-day distance milestone. A signal from Earth will take a full 24 hours to arrive. But time is running out. The nuclear power sources that have fueled these probes for decades are slowly decaying. One by one, the instruments are being turned off to save energy. Eventually, the signal will fall silent, and the Voyagers will become ghosts. They will continue their journey long after we are gone, carrying the golden record, a message from a species that once dared to look up. Across billions of kilometers, Earth continues to listen for a whisper from a machine built before many of today's engineers were born. Though they may one day be lost to the silence, their legacy is written in the stars, a testament to human curiosity and the will to explore. They were our eyes in the dark, our voices in the void. They were and will always be the pioneers of the interstellar frontier.
Deep in the moving forward into the infinite, reaching for the heart of the galaxy. This is the legacy of the Infinite Archive, a testament to humanity's reach and our eternal curiosity. Subscribe and join us as we uncover the next mystery hidden within the universe.